All right, continuing flow of our water going to the tanks. Like I said, the 3-inch is all the water being dumped from the gas production units and wells. Blanket gas system, what we implemented and designed on this to our tanks is we actually have gas, methane, flowing into this line, and we cut the pressure down to just a couple ounces, less than 2 ounces, and we keep a blanket gas in these tanks to displace any fluid that may be hauled or pulled down from the tank. We will displace that with blanket gas to eliminate oxygen, which will help slow down and control corrosion from the inside of the tank by eliminating the oxygen, and also by taking the oxygen out of the composition inside the tanks. That'll eliminate the potential of a fire from inside the tank. What we have here is our production tanks. It's designed to hold production water. Again, all of our condensate is not stored in these tanks. Not to say that we can't get some in there, but we do have ways to skim off that condensate if we do accumulate any during a failure, or maybe a sand trap got dumped or emptied a little aggressively. We may accumulate a little condensate in these tanks. We do have ways to skim that condensate off and recycle it back into the system for sales. Just to kind of go over how this all works, what we have is our loadout. This is where a truck would back into to pull fluids from the tank. We do have transducers on the tanks to protect us from high leveling. If for some reason weather or maybe scheduling wasn't allowing a truck to get on location to pull the fluids down, these are 240-inch tall tanks. If we get up to 200 inches, we'll send out an alarm to the operator so he can address or shut down the pad so we don't potentially overfill the tank. If we get to 216 inches, it's going to give us a high alarm, which will shut in the whole well pad. For sure, we'll get an alarm, operator will come out and address, and we'll take care of what we need. With the water being dumped into these tanks, sometimes you'll have some entrained gas into that water stream that will build up over time. These tanks are designed to not hold more than 16 ounces of pressure. If they do accumulate 5 ounces of pressure, what we have over here, this knockout bottle, is any vapors will come off of that tank and escape through this line heading towards what we call an ECD. Again, that's emission control device, a combustor, or it's an internal flare. You can see there's no exposed flare above the vessel itself. It's all internal. There's a tray of orifices in there. More pressure, the more orifices will light up to help burn off that excessive gas. There's a controller for this device to be able to set your parameters. It's tied to our PLC, it's tied to our SCADA, so we can monitor that through our phone, through our laptops as needed. It'll also have alarms tied to it, just like everything else. If the pilot goes off or if it gets too hot, it'll send out an alarm, and an operator or myself will come out and address that.